Swift Scholars, I'm Professor John Gallagher, and are you following the semester of Swift UI? Well, this video is a solution to one of the actual build an app questions in an in-class test that my students take as part of their course. A good time to try to solve this is after you've completed all the lessons through the Word Garden app. You should understand how to use all of the techniques needed to solve this at this point, and you should be able to complete this on your own. Now, in order to make sure that my students are sufficiently prepped for their code interviews and have good recall level knowledge, students complete this without being able to consult the internet or earlier code that they've written, but I do allow them to use a single page of notes and encourage them to add things to it like reminders on how to play sound in Swift UI, something that I think that most interviews would expect that you might have less recall level knowledge of. Now, this video is a little bit less polished than my standard lesson since it's simply a review of a solution, and if you stumble across this and want to take the complete course with over 100 tutorial lessons online, it's a 0 to full stack course, and it's free on YouTube, and I share the slides on my personal website. And if you're ready to challenge yourself, please feel free to pause after each question is presented on screen and give it a try. Just to show you, this is the app that we're going to build. It's a simple arithmetic tutor meant for very young children learning to add numbers from 1 through 10. You'll notice the UI starts by displaying the equation as well as the emojis for each number in the equation so that the child can count up the emojis if they'd like to and arrive at the answer. And when you click on a text field, the numeric keypad shows. When you type a value, the guess button becomes enabled. Backspace so there's nothing in the text field and the guess button is disabled. Click guess and the submitted answer is evaluated. If it's correct, we hear a happy chime and the correct message is shown in green. If it's wrong, we hear a wrong sound and the actual result is shown in red. The user can't click the guess button or click the text field until they've pressed guess again. There are a lot of beginning Swift UI techniques shown in this app, so it's a useful review as you continue early through your Swift UI journey. Hopefully you found this helpful, so let's take a look at the challenge and the solution. Now, the printed exam shows lots of examples of what the app looks like when it's complete. So right at the start of the exam instructions, I give you a URL where you can download the assets that are used in this build. So let's head over to our web browser and go to this URL. Highlight all the values in the MathTutor folder. You actually don't need the emoji doc, but if you downloaded this, no harm done. Then right-click, select Download. I'm going to save mine to the desktop, but yours is probably saving to your Downloads folder. Then why don't you head to the Finder and make sure that you've got the files that you've downloaded. And the first 3 questions in the exam ask us to set up our app's icon with MathTutor icon PNG, the launch screen with tutor-launch screen, and to add the 2 MP3 files because we're going to be using those in the app as well. So we'll head over to Xcode and we'll create a new project called MathTutor, create the Git repository. This is going to be nice to add to your portfolio. Then head to the asset catalog. I'm going to click on app icon, then head back to the Finder. I'm going to find the icon, MathTutor icon PNG, drag that over and drop it into the first 1024 by 1024 square. Then I'll highlight the rest of these files and drag them over into the asset catalog. Tutor-launch screen is the name of our launch screen files. I'm going to press return on that so that it looks like I'm editing, but I'll Command C to copy this name. Then I'll head to the project icon at the top of the project navigator, click on the info tab, head down to where it says launch screen, expand the expansion triangle. In the indented row below this, I'm going to click on the circle with the plus sign in it, select image name, then double click in the value cell and paste in the name of the launch screen files that I copied. If you launch your app in the simulator now, you should be able to verify that you've got both a launch screen and an icon. Now let's head over to our content view. And the next question says, create a text view containing a formula. And we should use variables that are named first number and second number. These should create an equation like the one shown below. The font should be large title. And when the app first appears, set first number and second number each to random values from 1 to 10. I also offer you some advice if you can't get the numbers to appear randomly when the app first starts. But I also show you how things should look if things are working properly. So let's head over to our app and build, and right under our content view struct definition, we'll create those variables with @state private var. I'll set first number equal to 0. It could really equal anything because we're going to change these to random values in just a bit. @state private var second number equals 0. Then I'll delete the image. We don't need this, and I'm going to keep the text view, but I'm going to change the text inside to the string interp plus string interp equals. The first string interp is going to be first number, second string interp is going to be second number. I'll set the font to .large title. And now here's how we get a random first number and second number when the app first runs. My students know you use the onAppear modifier. We'll add that below the VStack. We can just say .onAppear, and in between the curlies we'll say first number equals int.random in 1 and second number equals int.random in 1 We see over here on the right hand side we're already getting random values, and every time we click on the live play button in the preview we'll see new values show up. Cool! Next up, we create a value named emojis that contain 30 elements that are emojis. And you can either copy or paste the emoji elements from below, and you'll also find the emojis in the document at this URL, where we downloaded the MathTutor files. That's a Google Doc in that folder. I'll head to the browser and double click on this emojis document. There are a whole bunch of strings of the emojis separated by commas. I'm going to highlight and copy those. Head back to our app, and we're not going to be changing this, so we can actually create it as a constant with private let emojis equals, and in between the square brackets I'm going to paste in all of those strings. We've now got an emojis array. Now up next we should create two strings named first number emojis and second number emojis. We want to fill each with a repeated randomly chosen emoji with the count of the emojis equal to first number and second number respectively. So for example, if first number is 8 and you have a dinosaur emoji randomly selected, then you should have 8 dinosaurs. Similarly, if you've got a 10 and you select unicorns, you should have 10 unicorns. I also give you an option if you can't generate the random emoji lines, but you should be able to do that. The two emoji strings, first number emojis and second number emojis, should be separated by a plus. They should appear as shown below in default size 80, but you should be able to shrink these as needed. The emojis and the sign should also be centered. Put a spacer in between the emoji area and the equation, again as it's shown below. This is what it should look like. Let's build. Let's create the strings to hold those emojis. We could say @state private var first number emojis equals. We'll set it to empty string initially, and @state private var second number emojis equals empty string. Then down in onAppear, let's load up those strings with emojis. Now I didn't tell you specifically how to do this, and some of you might have done this. Let random emoji equals emoji.random element exclamation point. That chooses the random emoji. Then you can use a for loop to add those emojis to your first number emoji, like this: for I in 0 triple dot first number -1, open and close curlies, first number emojis dot append, passing in random emoji. And to show you this works, up top we're going to add text passing in first number emojis, and below this, to set the font to 80, we'll say dot font, and remember we pass in capital F font inside, and to get a font in size 80 we can say dot system and then add 80 to the size. Here I'm getting 7 lobsters for my 7 that's inside of my first number. Nice. Click that live play button and we'll see the preview will show us lots of different random options for our emojis and our first number. But Swifter, in class I showed you an even better way that we can create a string of repeated values. I'm going to delete the let through the end of the for loop, and I'm just going to do this. I'm going to say first number emojis equals string open parenthesis, and there's an option in here with repeating and count. Code completion says this creates a new string representing the given string repeated the specific number of times. You didn't have to do this, but if you're a member from our class demonstration, this is a super efficient way to accomplish this. Press return. The repeating value will be emojis.randomelement, add an exclamation point to the end so we force unwrap that optional. And for count, we can pass in first number. I get 9 T-Rexes. Nice. I'll copy this line and paste it down below with second number emojis equal to the same string initializer, but I'm going to pass in second number here. Then let's head up top. We'll add a spacer between our two text views. Copy that top text view, paste it down below, but we'll change the second one so that we pass in second number emojis. Look at that, burgers and lobsters. In between the text views, I'll pass in a third text view with the text of a plus sign. And you could put modifiers below all of these, but since they're all going to have the same modifier, what I'm going to do is put these in a group and then add the modifiers below so that they apply to everything inside the group. So with all 3 views selected, I'll type open curly, Xcode types the close curly, it indents these values. I'll put group in front of the open curly, then I'll cut out these font modifiers. And below this I'm going to add our font modifier where we pass in font.system with a size of 80. Let's center those emojis with dot multiline text alignment passing in dot center. And we'll shrink these guys down as needed with dot minimum scale factor passing in 0.5. That's looking pretty magnificent. On to the next question. Next, we should add a text field that should store a value that the user enters using a value named answer. Now we should set the font to large title, center the text in the text field, set the width of the text field to 60 points, place a rounded rectangle around the text field with a corner radius of 5 and a gray line of width 2, and have the number pad keyboard show when the user enters the data in the text field. We show what this should look like. This is very similar to what we did with our weather advice app in class. Let's build this. Even though the user is going to be entering numbers, remember anything in a text field is going to be a string. So we need to create a string variable up top at state private var. We said to call it answer equals. We'll initially set this to the empty string. Then down below our equation, we'll select text field with the option of title key and text. Press return. The title key are those ghost characters that show up inside the text field. We don't want any here, so we'll pass in the empty string, but our text has got to be a binding value. So we start that with a $sign, and that's going to be answer. Then we'll set the dot font to dot large title. We'll say dot frame, typing in a WI, and set the width to 60. And to add our border, even though we're going to use overlay, remember we always have to add dot text field style dot rounded border. That'll give us a uniform height even when there's nothing inside of the text field. And below this we'll say dot overlay, and in between the curlies we'll pass in rounded rectangle with the corner radius of 5 and dot stroke with dot gray, line width of 2. Now the question also asks to center the values that were entered inside the text field, and we do that with dot multiline text alignment, passing in dot center. Click in the text field. Now things are looking good. To add the number pad keyboard, we'll add the modifier .keyboard type, passing in .number pad, and we won't be able to see this until we build and run, so we'll click on that play button. Hammer time, looking good. We briefly see our launch screen. Here's our app running. Puppies and hedgehogs. Click in the text field. If the keyboard doesn't show up right away, it should. Just press Command K. We see the numeric keypad keyboard, looking great. Now I'll quit out of this, head back to our content view, and let's head on to the next question. So we should add a button below the text field followed by a spacer. The button should say guess, make the button style border prominent, and when there's no text in the text field, the button should be disabled. Once again, we show examples. Let's build. Below the text field, we'll enter the button. This is going to be the one with the title in action. The title is going to be guess. Press return for the trailing closure format. I'm going to put a to do for the button action in here and set the dot button style to dot border prominent. And to disabled, we've seen this in our apps. Not only in class, but also in WordGarden. We know it's the dot disabled modifier, and if we pass in answer dot is empty, this view, the button will be disabled when there's nothing inside of answer, but if we have something in answer, it will be enabled. Try this out. We see the button's disabled. When I enter something in the text field, the button's enabled. Backspace to remove it, the button's disabled. Look at that, pretty wizardly swifter. On to the next question. When the button is pressed, dismiss the keyboard. Check to see if the answered answer is correct, and if the answer is correct, play the correct sound. Otherwise, if the answer is wrong, play the wrong sound. Disable the text field and disable the guess button. Well, we know how to do this. To dismiss the keyboard, we need to establish a focus state and attach it to our text field. So up top where our state variables are, we'll say at focus state, private var, we'll call this is focused, bool. Remember, we don't initialize this, we just declare it and declare the type as bool. Then we need to bind that variable to our text field. So down below our text field, we'll enter a modifier that says .focused, and in between parentheses, we'll pass in $is_focused. iOS will then set the focus to true if we click inside the text field, but if we're outside of the text field, it will set the focus to false. But if we want to release the focus when the button is pressed, inside the guess button, we're going to delete this comment and we'll say is focused equals false. That's going to dismiss the keyboard if the button is pressed. Next, we want to check to see if the answer is correct. But before we can check our math, we've got to make sure that we can take a look at the number that is the answer. It's initially a string, but we'll convert that to a number. We can do that by wrapping the string answer in the int statement. But we also know that we might not be able to convert answer to an int. If the text we entered is not a number, maybe it's a symbol, maybe it's letters, then we'll get a nil if we try to convert this to an integer. So we'll use guard let for this. We'll say guard let, we'll call the value that we want to hold our integer answer value, lower camel case. We'll set this equal to capital I int. Between the parentheses, we pass in answer. This will either get us an integer or it'll give us nil. If we get a nil, the guard won't let us through, so we'll put in an else statement, open and close curlies, return. That means we have an invalid answer entered. But below this, we know we've got answer value as an integer, and we can check to see if it equals first number plus second number by saying if answer value, double equal sign, first number plus second number, and in between the curlies, We'll eventually put in some stuff to do for true, but we'll also add else after the curly and a set of open and close curlies for the false condition. Now we also know if we want to play audio, we've got to go up top. Now we need to create a variable for our audio player, but hey, before we do that, we should import AVF audio, and we've got to create an audio player, so we'll add an @state variable, private var, we always call this audio player, colon, we're going to declare it but not initialize it as an AV audio player, exclamation point. Always implicitly unwrap this optional. We'll add our function below our variable property, so I'll collapse the variable property, and just before the closing curly in the struct, I'll say func play sound, pass in sound name, colon, it is a string, open and close curlies, and Swift skillets, you know how to play sound. We're going to put in guard let sound file equals ns data asset, selecting the option with the string, passing in our name is going to be sound name, else open and close curlies. If this doesn't work out, we're going to return, but above this we'll also print out an error statement. Print could not read file named string interp sound name, and out front we'll put an angry emoji, add in all caps error colon. But if this works, the guard lets us through. We'll say do open and close curlies catch open and close curlies. And let's add the audio player to our audio player variable. We'll say in between the do's curlies, audio player equals, we have to say try because this might throw an error, AV audio player, select the option with data, and for data we're going to pass in sound file dot data, the data portion of the sound file we just read in. If this hombre jovene works, we're going to say audio player dot play, but if it doesn't work, we'll pass in another error message down below in the catch, and we'll convert this so that it says error. String interp will pass out error dot localized description. It can describe the error here because we threw that error. We'll add creating audio player, and now let's make sure that we call play sound when we press the button. Unfold that code, head down into our button action, and if the answer equals first number plus second number, we are correct, so we should pass in play sound with the correct string. If this doesn't work, in the else condition, we'll call play sound passing in wrong. Let us try this out. And gack, as mentioned, there is a bug in Xcode every once in a while when you try to enter into a text field in the preview. Instead, you corrupt your Swift file. The fix for that is pretty easy. Just open the project navigator, click on any other file, and then back on the file you were working on. Unfortunately, Xcode doesn't remember where the preview was, so I gotta adjust that, but now things should work. I'll enter a 10, click yes, and look at that, mellifluous sound because I guessed correctly. Let me reset the live preview. I'll enter a wrong value here. Oh, and I get the wrong wah-wah. Now remember, we also said to disable the text field and the guess button. So in order to do this, we're going to need to create two new variables. So up top, I'll @state private var. I'm going to call this first one text field is disabled and set it equal to false because I want it to be enabled at first. And @state private var button is disabled. I'll set that equal to false. Then down below in our button action, I'm going to set text field is disabled equal to true and button is disabled equal to true. Let's try this out. And ugh, this text field error is happening again. Let me fix that. I'll enter an incorrect value in here. Oh, I get the wah-wah, but I don't disable my buttons because I haven't updated my disable statements. Now we already have a disabled statement for our button view. Down here we disable it if we have answer.isEmpty, but we also want to disable it if the button is disabled as false. So what we can do is we can enter the OR statement with two vertical lines. So we'll disable it if the answer.isEmpty or button is disabled, entered after the two vertical lines. That'll disable the buttons if either of these statements is true. And under the text field focus, we'll say .disabled, and we'll set that if the text field is disabled. Oops, let me fix that typo. There's no dot out front. And now we can try this out. I'll enter a correct value. And not only do I get the correct chime, but I also see that the button is disabled and I can't get into this text field. Perfect. Next up, I want to add a text view below the spacer that's below the guess button. It should contain a message that should store a value named message. It should be in large title font with black weight, and it should be centered. And then below this, the text field that holds the message will be blank when the user can guess a solution. However, after the solution is guessed, it should change. If the user has guessed the correct solution, the word correct in green should display. And if the user has made an incorrect guess, then the message, sorry, the correct answer is correct answer in red, where correct answer is first number plus second number. Let's build that. So below the button view, we'll add another spacer. Then we'll add a text view. Oh, but we need a message variable for inside this. So up top we'll say @state private var message equals. Initially this will be the empty string. Then back down in that text field we can put message inside. The dot font is dot large title. The dot font weight is dot black. Dot multi-line text alignment should be dot center. And now let's update the message in our button text's if statement. And in the if true portion, we'll say message equals the string correct, capital C, exclamation point at the end. Else, the message will equal, sorry, comma, the correct answer is string interp, first number plus second number. Then we can head back to our text field and we can set the foreground style. Remember, that's how we set our color. And inside this, we're going to use a ternary operator. Remember, the first part is a true-false condition, so we'll say message double equals the string correct with an exclamation point with a capital C, exactly as we spelled it above. Then question mark, what do we do if it's true? We're going to pass in dot green. Else, what do we do if it's false? Colon, we'll pass in dot red. Let's try this out. We'll enter the correct answer in here and click guess. And look at that, we get the chime and we get the green correct message. Nice! Next up, also after the guess has been made, a button should appear below the message. It should otherwise be hidden, so we've got a conditional in there. This button should be the default style, which just looks like the text in blue or whatever the accent color is, and the button should read play again question mark. Note that you can only click the play again button at this point. The text field and the guess button should both be disabled. So at this point the app should look something like this. We can see examples of it being disabled as well as enabled. Let's build this. So below this we'll add a standard button with the title key in action. The title is play again question mark, and inside the curlies of the action I'll just put in a to-do saying button action, but this should show up conditionally. So this button should be enclosed in an if statement. Above the button I'm going to put in an if statement that says if message not equal empty string, don't forget your curlies. And remember, if the message doesn't equal an empty string, well then we must have something inside that either says we have the correct answer or the incorrect answer, the wrong answer. So I can cut out my button and place it inside this if statement. That will show the button conditionally. Let's try this out. We don't see any button yet, but if I put in a guess in here, oh, it's correct, and I see the play again. I can't click on my text field, I can't click on the guess button, I can only click on the play again button, but we've got a bit more logic to put in here. Let's head back to the midterm. And this is the last part of the test. If the play again button is pressed, the correct incorrect message should be empty. The play again button should be hidden. The text field should be made empty. The text field should be enabled. The guess button should be enabled again at this point. When something has been entered into the text field, it should continue to disable if empty. And a new equation with newly generated random values for first number and second number should be presented to the user, along with the appropriate emojis representing the numbers in the equation. Random emojis should again be chosen to represent the first number and the second number. If the emojis are repeated, that's okay, but they'll usually be different. And when values for the emojis equation and message change, animate their respective text views using the default animation. And at this point, the game should play perfectly. Random values should show up at the start. The user should be able to guess using the number pad keyboard. The guess button should enable when someone enters an answer or disabled when no answer is present. Pressing the guess button should evaluate if a guess is wrong or right and show the message in the appropriate color and play the appropriate sound. This should also show the play again button. The user should not be able to click on the guess button or enter a new guess until they click on the play again button. Clicking play again should also hide the play again button and prepare another guess with a new value so that the guessing can continue. Let us complete the awesomeness. So we now need a button action inside of our play again button, and this is going to be message equals empty string. Answer equals empty string. Text field is disabled equals false. Button is disabled equals false. But remember, we've got the or conditional up here where we're going to disable the button if either the answer is empty or the button is disabled, so this is cool. And at this point, we want to get a first and second number randomly and also assign random emojis. But hey, we already did that inside the curlies of our onAppear modifier down here. Why don't we take the statements we have in here and create a function so that we can reuse it both in onAppear and in our play again button. So I'm going to copy these lines of code. I'm going to head to the bottom, just before our closing curly, and we'll create a new function. You can call this whatever you want, but I'm going to call this func generate equation, open and close parens, open and close curlies, paste in those 4 statements. Then I'll delete them from on up here, and I'll enter generate equation with the open and close parens here. And I'll also bop up here to the action inside of our play again button, and the last statement in here will also be a call to generate equation. Now remember, we also want to add some animations, so let's go up here to the text view with message inside. We'll say dot animation, select the option with the animation and the value. The animation should be dot default, and the value should be message, so this is going to be triggered when the message changes. Let's do the same up here for the text field that shows the first number plus the second number. So we'll add dot animation, again with the animation and value. The animation will be default. And you know what? Since the first value or the second value might be the same, what I'm going to do for my value in here is I'm just going to put in message. I know that the message is always going to be cleared out, so it's always going to change if I have a new set of values that have been generated, so this will work perfectly. I'll copy the same animation statement, and I'll put it in here underneath the group that's got my emojis and my plus sign. And friends, why don't we build and run in the simulator and see how things look? Oh, legends, look at this. Monkeys and an owl. I'm going to enter a 7 for this. Guess button enabled. Backspace, guess button disabled. Enter again, guess button enabled. Working good. And that's a correct guess! My text field is disabled, my button is disabled, but I can click on play again down here. Ooh, and a hedgehog and brains. Let me put in an incorrect guess this time. I get the wah-wah, a sorry message. It's in red. Nice. I can play again. Aliens and butterflies. That's correct. So feel free to play as much as you'd like, Swifter. I hope the exam went well for you. Make sure you correct any issues that you had on the exam, and then post this to your GitHub portfolio. This is going to be a nice app to show off to potential employers. And if you struggled, hopefully everything's clear. If you need to go back and review any lessons or any of our slides, make sure that you do that. You want to make sure you got this down. If you're one of my students, come see me or TA if you have any questions. If you found this challenging, don't be discouraged. There's still lots more of our course and lots more opportunity to up your grade. I know you'll improve. Keep at it.